Hello, good morning. Our lesson today is about ratios. Now, we use ratios in everyday life. If, let's say, I am making a pastry and I need a recipe for my pastry. Now, let's say my recipe is 500 grams of flour mixed with 250 grams of butter. And then I'm asking you, can you find the ratio for how many grams of flour to butter in this recipe? You will say, I am using 500 grams of flour and I'm using 250 grams of butter. Now, if I ask you to give me the inverse ratio, like say I am asking to give me a butter amount or grams to a flour ratio, you will say it is 250, the amount of butter that I have, 250 grams to 500 grams. Now this is called a ratio, and this is called a ratio. A ratio is a comparison between two or more quantities. Now, if I ask you to simplify a ratio, you will do it by dividing the numbers to the highest common factor. Like in this ratio here, I will divide the whole ratio by the highest common factor. Now, the highest common factor, you will need to find that. We did this in previous lessons. If, for instance, for this example, the highest common factor is 250. So you can say 250 divided by 250 is 1. 500 divided by 250 is 2. So this is the simplest form of this ratio. Of course, you can say like, I can't find the highest common factor that easily, it'll take me too much time. Then I would advise you to use the smallest prime numbers. The smallest prime numbers are 2, 3, 5, and 7. You can always start dividing by these four numbers. Of course, if you start dividing by 2, you might have to redo the division by 2 or 5 or 3. Like, I'll give you an example. If you refer to your course book, page 141, you will see that the exercise (14.1). Question 1. A. I am asking you to give me the simplest form of this ratio, which is 2 to 10. Now, the simplest way is by dividing by the highest common factor. Or you can start dividing by one of these numbers, but there is a condition. Both numbers need to be divisible by the same digit. So I can say 10 divided by 5, but I can't say 2 divided by 5. It will not give me a whole number. So I need to try something else. I can divide by 2. So it'll be 2 divided by 2 is 1. 10 divided by 2 is 5. So our new ratio will be 1 to 5. Now this is the simplest form of this ratio. If you look at question 1 in the same paper, B, I am asking you to give me the simplest form of 3 to 18. You will say 3, if divided by 3, will give me 1. 18 divided by 3 will be 6. So this is the simplest form of this ratio. Instead of 3 to 18, it'll be 1 to 6. Both of these ratios are called equivalent ratios. So equivalent ratios mean both of these ratios are equal. Now let's do C. 5 to 25. When you divide by 5, you'll get 1. And 25 divided by 5, you'll get 5. D. 30 divided by 5. You can easily see that both numbers are divisible by 5 because one ends in 5 and one ends in a 0. So 5 divided by 5 is 1. 30 divided by 5 is 6. Now let's look at E. 36 to 12. This is more of a bigger ratio. Now, you have many options. Let's start. I am saying I don't know the highest common factor. I'm going to use the smallest prime numbers. So I'm going to start dividing by 2. 12 divided by 2 is 6. 36 divided by 2 is 18. Now I have 18 to 6. I know that both numbers are even, so both numbers can be divided by 2. Or I can divide both numbers by 3. Or I can divide both numbers by 6. Let's say I only wanted to divide by 3. It didn't occur to me to divide by 6 or 2. So 6 divided by 3 is 2. 18 divided by 3 is 6. Now I have 6 to 2. I need to divide furthermore because this is not the smallest form of this ratio. So 12 divided by 2 is 1. 2 divided by 2 is 1. Sorry. 6 divided by 2 is 3. This is the simplest form of this ratio. Of course, if from the beginning you didn't want to divide by 2, then divide by 3, then divide by 2, you can just say divided by 12, give me 1. 36 divided by 12 will give me 3. You can divide by 12 all at once. And like this question is question in F, you have 180 to 20. I know that both numbers are divisible by 5 or 10 or 2. So let's try 10. 180 divided by 10 is 18. 20 divided by 10 is 2. Now if you divide furthermore by 2, because both numbers are even numbers, you'll get 9 to 1. Let's look at question G. You get 4 out of 6. Both numbers are even numbers, exactly. So you'll get 2 to 3. 9 to 15. If you look at both numbers, this number can be divided by 5, this number can't. This number can be divided by 3 as well as the 15. So now you can divide by 3. You'll have 3 to 5. Those are the answers circled for you. Now we're at I. 10 to 35. If you divide by 5, because both numbers are divisible by 5, you will get 2 to 7. This is a ratio in the simplest form. If you look at J, 75 out of 10, 75 to 10. Both numbers can be divided by 5. 75 divided by 5 is, 15. And 10 divided by 5 is 2. This is the smallest ratio. Okay, 72 divided by 20. You can start by dividing by 4. You'll get 5. If you divide the whole ratio by 4, you will get 5. 20 divided by 4, 5. 72 divided by 4 is 18. Last question. 140 divided by 112. You can say that I don't know what is a common factor for both of these, but I know that they are both divisible by 2. And you can start dividing by 2. You'll have 70 and 56. So it's 70 to 56. Also, both numbers are divisible by 2. You'll get another ratio. You'll get 35 to 28. Now, both of these numbers can be divided by what? Like this number can be divided by 5, but it cannot be divided by 2. And this number can be divided by 2, but can't divide it by 5. If you look at this slide, we said the smallest prime numbers are 2, 3, 5, 7. We'll do a test here. 35 divided by 2, it doesn't work. By 3, it doesn't work. By 5, it does work. So let's see if 28 can be divisible by 5. No, it doesn't. So we'll try 7. 37 divided by 7, it works. It will give me 5. 28 divided by 7, it works, it will give me 4. So this ratio will be 5 to 4. This is an example of how you can look through your options to find the highest common factor. Now, if you look at question 2, it's a little bit different, but the same idea. In the same page, 141. Question 2 is asking you to simplify ratios that are comparing more than 2 quantities. I have 5 to 10 to 15. I have here 3 numbers. I'm comparing this number to this number to this number, but it will be, if I'm asked to simplify the ratio, it'll be the same way. It'll be the same steps. 5 divided by 5, the whole ratio will be divided by 5. It'll be 5 divided by 5, 1, 2. 10 divided by 5 is 2. 2. 15 divided by 5 is 3. So our new ratio will be 1 to 2 to 3. Now, if you look at B, you have 8 to 10 to 12. This 8 the whole ratio can be divided by 2. So 8 divided by 2 is 4, 2. 10 divided by 2 is 5. 12 divided by 2 is 6. The following question. The whole ratio can be divided by 5. 20 divided by 5, 4. 15 divided by 5 is 3. 25 divided by 5 is 5. Now, 18 to 15 to 3. You can also, like a little tip, you can also start dividing by the smallest number of the ratio. Like the smallest number here is 3. So start dividing by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. 18 divided by 3 is 6. This is the simplest form. As soon as you get 1 in one of the digits, you'll get 1. This is the simplest form of this ratio because 1 cannot be further divided by any number and getting a whole number. You have 27, 9 to 45. If you try dividing by the smallest number, 27 divided by 9 is 3. 9 divided by 9 is 1. 45 divided by 9 is 5. So your new simplest ratio will be 3 to 1 to 5. Our last question, or last branch of question 2, 72, 16, 32. You can divide by 4. The whole ratio can be divided by 4. You'll get 32 divided by 4 is 8. 16 divided by 4 is 4. 72 divided by 4 is 18. Now this whole ratio can be further divided by 2. You will get 8 divided by 2 is 4. 4 divided by 2 is 2. 18 divided by 2 is 9. This is the simplest form of this ratio. Now, question 3 has one more idea into it. Question 3 in the same paper is giving you quantities with units, like measuring units. You have 500 meters to 1 kilometers. In this question, you need to change the units because you need to make sure that all the quantities are in the same units. So you need to change the the kilometers into meters. So you will say the 1 kilometer will be timed with 1,000 because 1 kilometer times 1,000, it'll be 1,000 meters. This is how we convert from meters to kilometers. Now, this is a new ratio. Both units are the same. Now we can find the simplest form of this ratio by dividing by 500, trying to divide by the smallest number. So 500 divided by 500 is 1, 2. 1,000 divided by 500 is 2. So the simplest form of the ratio is 1 to 2. Now if you look at B, you will see 36 seconds to 1 minute. I am always trying to convert the larger unit, which is in this case minutes. In the previous case it was kilometers. It's bigger than meters because I want the numbers to become whole numbers. If I say 36 and I convert it to minutes, I will get a fraction or a decimal. I will not get a whole number. Now you can see here the 1 minute, how many can be converted to seconds. 1 minute equals 60 seconds. And I already have these 36 seconds. Now this is the new ratio, which is 36 to 60. You can say 36 divided by 6, you'll get 6. And 60 divided by 6, you'll get 10. Now, 6 to 10 is a smaller ratio, but it's not the simplest ratio because both numbers can be divided by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. This is the smallest and simplest form of this ratio. Let's take a look at C. I have 800 milliliters to 2.4 liters. Let's try to convert the bigger number, the bigger unit, which is liters. I have 2.4 liters. If I turn it to milliliters, this is the first step. 2.4 liters times 1,000. I'll have 2,400 milliliters. This new number will be used in my ratio. Now, I can divide both numbers by 100. I'll get 8 milliliters to 24 milliliters. Of course, you can divide by 800 all at once, but I'm trying to show you that there are more than one way to get the simplest form. I'm trying to show that some of you might use different ways to do different things. Now 800 divided by 100, you'll get 8, and 8 divided by 8 is 1 milliliter to 3. Because 24 divided by 8 is 3. Now, of course, you can say 800 divided by 800 is 1, 2,400 divided by 800 is 3. But I'm trying to show you different ways to get to the smallest ratio. Now, if I'm asking you to refer to your course book, page 141,